This is the next lesson on ionic and chemical equations. In this lesson, we're going to be looking at precipitation reactions represented by full chemical equations and ionic equations specifically. We know that when you have two ionic compounds, they react together in solution, they can form a precipitate, meaning an insoluble product. Those can be represented by a chemical equation, complete chemical equation, which is shown below here. We also can represent them as ionic equations. And the purpose of representing them as ionic equations is so that we can look at the species or the individual components that are reacting in this experiment. So a chemical equation can be shown as this, as you've seen before, silver and nitrate reacting with sodium chloride, which forms silver chloride and sodium nitrate. You can see that we began at aqueous here, we form the precipitate or the insoluble compound, the insoluble ionic compound. Now, if we were to represent an ionic equation, what you need to do is you first split up the reactants into their respective ions. The silver is in 1+ ion, aqueous form, nitrate, aqueous form, 1-. Sodium and chloride are both aqueous form, +1 and -1. Then we form silver chloride as a solid. So here is again our precipitate. We have sodium as an aqueous form and nitrate aqueous. So from here, what is actually reacting? Well, anything that's changed state is known as reacting in this experiment for our purposes. So the nitrate ions begin as aqueous, finish as aqueous, meaning they are not reacting. Same as sodium, begin as aqueous, finish as aqueous, and not reacting in this experiment. The only parts that are reacting in this experiment for an ionic equation are silver and chloride. So if we were to write a chemical equation, it would be silver, Ag+, plus chloride minus aqueous form, and that would be forming silver chloride solid. That there is our ionic equation showing the reaction. The crosses are through the ions which are not reacting and therefore leaving only behind the ionic equation. This here is just a representation of what I just spoke about, and it's showing that sodium and nitrate do not react with the species in this reaction, therefore they're known as spectator ions, meaning don't react, not involved in the ionic reaction or ionic equation. If we do another or a second precipitation reaction and we represent it with a chemical molecular equation or a ionic equation, this is how it would look. First of all, we have lead nitrate, aqueous form, plus sodium iodide, aqueous form. It combines together to form a precipitate, lead iodide in solid state, and then sodium nitrate in aqueous state. We can see that nitrate began as aqueous and finished as aqueous, so it's not involved in the reaction, nor is sodium involved in the reaction, began as aqueous state, finishes aqueous state. So the only things reacting or changing state is lead nitrate, which began as aqueous form, iodide, which began as aqueous and now has formed solid state. The ionic equation would simply be taking these ions, lead plus iodide with the correct ratio, 2 in front there, doesn't need to be balanced, lead iodide. And this is our ionic equation here. Lead ions, aqueous form, plus iodide, aqueous form, gives you lead iodide in the solid state. That's your net ionic equation, and your sodium and nitrate are spectator ions. Summary of today's lesson. First of all, you write down your positive ion, then your negative ion. So if you had AgCl as a compound, write them into their respective ions. It will be easier to determine what's reacting. From there, you then match those with a particular metal or non-metal, depending on what you're using. So here we've split sodium and we've split nitrate. And there you match the first metal over here with the second non-metal. And the same again, the second metal with the first non-metal to complete your reaction. From there, you then move to check which compounds are soluble and insoluble in water, and you write the respective states. Then you balance the chemical equation to ensure the same amount of products reactants. And finally, you observe which reactants or products are changing state, and then you can eliminate which ones are involved in the reaction and therefore which are part of the ionic equation and which are not, which are spectator ions and which are not. These are the questions I'd like you to complete, 1 to 3 of page 331, chapter 313.4.